consultant, founder and director at Urja Building Services Consultancy. Starting UBSC with a 3 month baby in her arms, and now she has taken UBSC to a leading MEP consultancy with over 400 projects and 80 million square feet of work done worldwide. She has a wide experience of MEP design of skyrises, townships, commercial buildings, retail malls, institutional and urban design projects. Today, Ms. Bhilkar is going to be talking about MEP considerations for easy maintenance in skyrises. So let's welcome Ms. Sheetal Bhilkar.
MEP considerations for easy maintenance of high rises. So MEP consultant's role in any building plays a major role, and especially in high rises. If you have already seen statistics of my company, we have designed more than 400 plus projects, and out of that many of them are high rises. And in case of high rises, MEP services are backbone of that building. So MEP consultants plays a major role in designing any high rises. So role of MEP consultant start at the beginning of any project, right after architect completes their primary planning. MEP consultant should be appointed for any high rises, because initial planning of services is very much important for any building. So I would like to start with services core. So I would like to talk about that more, because core of a building is very much important, and core area should be sufficient to carry fire stairs, elevators, electrical, ELV, firefighting ducts, HVAC shafts, everything. So this is an example of a 39-story building where ducts are not provided, and we have to put ducts in this near the this shafts. So core of building is usually designed by buildings in the tightest possible ways. So as a MEP consultant, we should see to it that proper duct should be provided and it should be maintainable. So at the beginning of project only, MEP consultant should put their foot down, saying this much space is required. Otherwise it becomes very difficult to maintain later on. So as per NBC 2016, they have introduced aspect of fire tower in high-rise buildings. So in fire tower, it includes fireman's lift, staircase, fireman's talk back, and wet riser and hose reel. So this concept of this fire tower is that fire and rescue services should safely reach and work close to the fires. So while we design the building, so services spaces are very much important. So electromechanical equipment, roof sizing and location is very much important in any high rises. So planning and designing of adequate equipment spaces is very much important, because equipment room shall be designed that way that it should be within the building footprint. Its location should be near the shaft. Then equipment removal and replacement routing should be planned in the beginning, because in maintenance point of view, if you are not planning all these things in the beginning, later on it becomes very much difficult. If you want to remove a panel, or if you want to remove a DG set and you have not thought of it, so it becomes very difficult in maintenance point of view. So everything should be planned in the beginning only when you are placing that equipment. And whenever you are placing this electromechanical rooms, that time you should think also about the dB level. Suppose you are placing it near the auditorium, it is not advisable, because if DG set is there or some fan is there, that noise will be there. So you have to think in all these aspects when you are locating these rooms. So service floor is very much important and should be planned at every 100 to 120 meters. Also for mixed use projects, like sir had given example, the top floors if they are commercial and bottom floors are residential, or vice versa. In that case, you will have to have a service floor in between to divert all the services, and even tanks, ventilation fans for staircases, lift lobby pressurizations can be planned there. So outdoor locations is becoming day by day a very big issue for high rises, because this placement of ODUs, likewise in Mumbai, you really don't get spaces for all these things. But then proper ventilation of this ODU is very much important, for because every degree rise in outside temperature leads to 3% energy loss. So you should always think while placing this outdoors strategically. Also, you have to study the stack effects. If multiple number of outdoors are placed in a duct, you have to think of stack effect also that time. Now I'll talk about electrical consideration, which is very important subjects in high rise. So high rises, typically we used to use cables all these years, but for in case of high rises, it is really not advisable to use cables, because imagine this case where a 37-story building which has 140 flats. So in a cramped duct, you can't take 140 cables together, it is a fire hazard. So instead of that, if you go for a bus duct, rising mains, that saves space also, and it is very superior products than bus duct, than cable. So like space requirement is less, then temperature responses and derating in case of bus duct is much superior. Fire safety wise also bus duct is much superior. Then installation time is very much less in case of bus duct over the cables. Then even overload capacity of bus duct is much more. It can take up to 150 degrees Celsius. Even short circuit capacity of a bus duct is good. So in our all the projects, wherever we are designing high rises, we are recommending bus ducts, and supply companies also nowadays are giving permission. Even MSEDCL, now they have started giving permission for rising mains. Otherwise we used to face this problem with projects in Thane, where we were not getting permissions for bus duct, but nowadays they are also giving permission for bus duct. So we are widely using this solution for high rises. This is example, we have done this at a tower at Daisar, bus duct installation. Then again, fire survival cables should be used for life safety, which is mandatory as per fire NOC, but some people they don't follow this. But as a consultants, we should ensure that all builders are using this fire safety circuits with fire protected fire survival cable. So emergency power supply, firefighting elevator, fire pumps, fire alarm circuits, voice communication, firefighters handsets, emergency power for lighting, pressurization fans, smoke dampers, smoke extract fans. All these circuits should be fed with fire survival cables. Then in case of DG set also, the selection of DG set is very much important for high rises, because the DG set calculation, when you do, you have to consider the fire, the load in fire condition, and in that way only you have to select the DG set. You just can't select DG set considering common area load. You have to consider firefighting load and starting current of the highest motor while designing your DG set. This is very important factor. Then even ELV cables, maintenance point of view, if you see traditionally people use Cat5 or Cat6 cable for internet, telephone, but Cat5, Cat6 cables, if you see, rats like this jelly filled cables a lot, so they chew that, and then you get lot of maintenance issue. So there is superior solution called fiber to home, that is FTTH cable. These are all fiber cables, so your ELV duct size reduces a lot. So for high rises, we are widely using this solution, where this FTTH solution we are giving to all our customers, where they get higher internet speed, and even maintenance is very easy. You can say it is minimized, Then of course BMS is designed for all the high rises, where all maintenance schedules, preventive maintenance and maintenance schedules you get on your mobile. So you get pumps, STP, DG set, all this maintenance schedule you get on your fingertips. So this we have to do for all the high rises. So that reduces, if you do preventive maintenance properly, then the maintenance problems you don't get much. Then again, water leak detection you have to suggest for lift pits. Okay, now I'm going to talk about the most crucial, that is firefighting design considerations. So, of course, we design automatic sprinkler systems for to detect fire and extinguish with water or extinguisher agents at early stages. So that the fire, it should not hold the fire in compartment and not allow it to spread in the building. So types of sprinkler, as we all know, wet type sprinklers, dry type sprinklers, foam fire sprinkler system, pre-action, deluge, all the sprinkler systems we use. Then refuge area need to be planned with talkback system, so that with call with fire command center shall be established. Then egress path should be designed properly, where with exit signages, fire rated doors, hold open devices, emergency lighting, all these things you have to do. Fire alarm system also plays a very important role because it detects the fire at early stage. So this designing is also important. That this is a smoke extraction system for a building which we have designed. So precision in the designing of smoke extract system is also required. So smoke extraction systems you plan for exits, lift lobbies, passageways, corridors, basement car parkings and common areas. So next is the plumbing consideration. Plumbing also plays a major role in high rises. So in high rises, what we do is vertical water distribution piping, that we divided into multiple hydraulic zones, so that we have better control over water pressure. So, and the advantages, in case of failure of one circuit, users on all other floors, they don't get suffered because of that. Or also issue of leakages in joints, especially in basins and health faucets due to excessive pressure, and even the splashing of water in basins, sinks can be avoided by this. Then you have to select this PRVs, pressure release valve, properly, because this malfunctioning of this PRVs or improper location of this PRV can cause multiple problems like leakages in joints and even excess pressure. So PRVs should be selected to avoid cavitation, and selected PRV should ensure that the ratio of inlet and rated outlet pressure is maintained as specified by OEM. Even in drainage, so when you are designing draining, you have to make sure that the all drain fittings are connected to the vertical stack or underground sewer should have minimum 50 mm water seal, that you have to ensure. Or also the designer should compensate for thrust that occurs in the change of direction in the pipes, where the thrust block should be used, restraining joints that mechanically anchor the fittings to the entering the and leaving the pipes. So that care should be taken. A ventilation system should be designed for the flow of air in the drainage piping network, which is a very important point, and sometimes designers forget that. So this should not be missed. In a high-rise drainage, the vent stack shall provide pressure equalization and relief throughout the system. This is also a very important point one should remember. And see, as a consultant, we design the building, work is executed, but at the time of handing over, the care should be taken whether the as-built drawings are proper, because maintenance point of view, you have to see the proper as-built drawings are there, because what contractors do otherwise is they just give the working drawings given by consultants and they hand over saying these are the as-built drawings, but actually that should be checked properly that they are actual as-built drawings, because maintenance point of view, this plays a very important role. We have seen some sites where we were doing due diligence that this proper as-built drawings are not maintained, and then this maintenance team, they don't know how to maintain this proper this where the cables are going, they don't know the routes properly. Even O&M manuals for all MEP equipment should be maintained. Labeling of all panels, DBs, equipment shall be done properly. All cables shall be tagged at both the ends. or pit marking should be done properly, and you have to ensure that all shafts are closed by fire material after installation of piping or cables. This should be taken care of. So I'm not going to talk about much about maintenance, because my other panelist is going to talk about maintenance, but yeah, these are the 3 types of maintenance, and I'll surely give few tips about maintenance of MEP. So first of all equipment room access should be clear. Many times what happens after handing over, people use those passages for different things, and then something is lying there, and when maintenance comes, that time that access is not clear, so that should be taken care. Then every 6 months cleaning of all compartment, tightening of power and control connections for panel should be taken care. Visual checks for red spot in panel should be seen. Then visual check for corrosion in on-control panels every 6 months. Functional test for fire emergency panels is very much important, because these are all life safety systems. Then even DG should be run, DG test run should be done, because in Mumbai usually this electricity is not shut off and the power failures are not much, so this DG is not running, and when actual need is there, that time then that DG does not function. So this DG test run is also important. DG synchronization test, bus duct thermographic survey, all these things are very important. Even the mock drill for firefighting every 6 months is very important. Plumbing pipes, tanks, fittings should be checked for leaks, noises, cloggings. Then even exhaust fans should be checked whether they are clean and running smoothly. Then checking of all pumps should be done regularly. Even clean this air filter should be clean and replaced every 6 months. All these are maintenance tips that should be taken care. So I would like to end my presentation with sharing with all my designers that it is our goal to hand over to a client a facility that will work like a well-oiled machine, not the one that keeps on crying for attention like spoiled child. Thank you.